at Parity, and now a few months ago we start Rock with that thing in mind of having a better experience for developers to build the solution in Polkadot using POP. Why this was born? So we are a team of six developers that have been the last 2 years working at Parity, helping supporting parachains, supporting developers, in making integration into Polkadot, building some parachains, and we have some experience with that. We saw that the process can be improved in different ways, and that's what we are trying to achieve with building POP. That's the platform that we are going to see in this, or we are going to use in this workshop. So the agenda, as I say, is going to be more practical than theoretical, but I have to do some intro. So at the beginning, I'm going to start with an intro on smart contracts on Polkadot, and then we're going to jump straight away into the first part of the workshop, which is going to be set up a parachain locally for testing the smart contracts with POP CLI. After that, a bit of an intro on the basics of Ink, the smart contract language that we are going to use to develop smart contracts. We are going to jump then into the second part of the workshop, where we are going to deploy the smart contracts using POP. We're going to create, build, and deploy the smart contracts using POP. And then the last part that I think is very interesting for you for the hackathon is how to deploy that in a testnet, so you can have like a real solution, a testnet solution at the end of the hackathon. And finally, I'll have time for questions, but I'm a mentor in this hackathon, so if you don't have any questions now and you have it later, I will be around Discord, so you can ask me any questions, and I will be very happy to help. A bit of an intro of the Polkadot development. I know last week was there was a workshop about Substrate and Polkadot, so I'm not gonna go very deep into that. But there is a difference between Polkadot and other ecosystems, blockchain ecosystem like Ethereum. Ethereum, for example, is just like a layer 1 blockchain where you can deploy your smart contracts. Polkadot offers more than that. It has Substrate as a framework to develop your own parachain, which is a layer 1 blockchain that is connected into Polkadot to get the security that Polkadot offers and to get the interoperability with the rest of the different parachains in the Polkadot ecosystem. That's really cool because you can have up and running a blockchain, and you can have the business logic of your idea in a blockchain level, developing the runtime of your blockchain instead of in a smart contract on top of that. The problem with that is obviously that you have it's more complicated to develop, more complicated to maintain that a smart contract, which makes the smart contracts still a very interesting approach to develop your idea. It has less technical freedom, less performance, maybe a bit less security, but still it's a very, very, very nice start to develop and deploy your idea, and then you always can iterate and migrate into a parachain, starting with a smart contract, which, for example, in things like a hackathon where you are now, I think it's a great idea. Again, I'm not gonna go a lot into Substrate because you already had a workshop last week. But with Substrate, you can create your own blockchain where you have things that you probably don't care. You only care about the business logic. So with Substrate offers you all the consensus and all the node functions that you don't have to implement yourself. Basic things in the runtime, like the balances, you can take some of the existing modules, which is called Substrate frame palettes, and just integrate it into your runtime. Like if it's like I like to see like a Lego. So you just take the models that you want and integrate it in your runtime. The ones that we are interested in this workshop will be like the contracts palette. Contracts frame palette will see it's the module that will allow your parachain, your chain to deploy smart contracts on top of this. If you want another kind of smart contract, which are the ones used in Ethereum, EVM smart contract, you can add this module that we have here, this frame palette that is called EVM palette, which emulates how an EVM works. EVM is the Ethereum virtual machine functionality. It's emulate that on top of a Substrate chain, so you can deploy Solidity smart contracts on that. So I like this image because for me it's very clear. You have your blockchain implemented in Substrate. On top of that, you are adding the pallet contracts. The pallet contract, that is the module that allows you to deploy smart contracts on your blockchain. It has this API for WebAssembly bytecode that it understands a WebAssembly code, chunk of code that you generate when you develop and compile a smart contract. So you can go only if you are a smart contract developers. That's which is the goal of this workshop. You are just using Rust or other programming language like Solidity or other ones. Develop your idea, develop your smart contract, and that will compile into WebAssembly bytecode that then you can deploy into this blockchain. So yeah, that's the intro. Let's start doing things. Let's start the workshop. So the first thing that we're gonna do is set up a contract, a parachain, set up a parachain that has this contract palette on it that will let us testing a smart contract locally. For that, we're gonna use Pop CLI. As I said, that's a tool me and my team is building right now. So you can scan this QR code, or you can go to GitHub.io Pop CLI. Pop CLI is a tool, an all-in-one tool for Polkadot development. So you can install the dependencies that you need for Polkadot development. You can create a parachain in a similar way. If you know a bit about front-end development, in a similar way as Create React App can create you a template to start building your front-end application. So here we'll see now, like you can create a template, a parachain to start running and to start developing on that with one command. You can build and you can set up this environment. You can build, you can create smart contracts, you can deploy the smart contracts on a parachain, and you can call and interact with this smart contract. So it's basically an all-in-one tool for this Polkadot development. I encourage you to go into the GitHub and clone it. You can install it with this command here, but everything is in the README in the GitHub. So let's do some coding now. I already have pop installed here, pop CLI installed here, so I can run pop with the flag help, and I can see all the commands that I have available. So I can, as I was saying, the first thing probably you should do is to run the pop install. That will install all it will detect what's your operating system. In my case, is MacOS, and what package I need to install. It shows you that's coming from the documentation. It's telling you what package you have to install for the Polkadot development. Right now, I already have this installed, so I will say no. I see some questions. Okay, we'll talk later about the standards. When we arrive into Ink, we can talk about that. Let's keep doing the first part of the workshop. Let's talk about, let's create a new parachain. So something as simple as pop new parachain. And that will show us the different options that we have, the different templates that we have to create a parachain. First, so we have like different providers. The native one in the Pop platform are 4. Then we have some templates that we can take that are maintained by Parity. Let's pick one of the ones in Pop. So we have, for example, a standard parachain that is just a parachain that doesn't have anything relevant. Assets one that has configured to work with NFTs and different assets. Then we have the EVM, as I say before, so it has Frontier and it enables compatibility with, you can deploy here EVM smart contracts. And the one that we are gonna use is the contracts template, which is a parachain that supports WebAssembly smart contract. That is the smart contract that we are gonna develop using Ink. So I pick this option, then I pick the specific release, in this case the 1.9. I give it a name to the parachain, Prodigy template. And then I can customize this parachain, so I can pick the symbol of the token, how many decimals, and the funding that the dev accounts are gonna have. So once we have that, we have the parachain here up and running. We have the parachain, so we can go, it's saying here, seed into Prodigy template. And we can, if I open now the Visual Studio Code in that, I can show you what has been generated with this POP. So it has been generated a parachain template that is ready to be run and ready to start developing on that. It has all the part of the node that makes the node interact with other nodes and have the consensus and generate blocks. And then it has the runtime, which is the business logic of this template. In that case, what we want to see is check all the palettes, all the modules that it has. So we can see we have like basic one, like the balances, and the one that we are more interested for this workshop, which is it has the palette contract on it. So second thing we want to do is to build this parachain, pop build parachain. That's gonna build the parachain. That can take half an hour. So for now, let me stop it and open another template that I already built it, so we don't have to wait half an hour. Clear. So now what we want is to pop up. So what we want to do now is to run the parachain, to be able to develop a smart contract on that. So let's see, pop up parachain. Let's see, help command that will help us understand what this is doing. So to set up a parachain, we need to have a relay chain. We need to have the Polkadot chain app working, and then we have a parachain working and connected into this relay chain to be able to generate blocks and to be able to develop a smart contracts on that. For that, Parity developed this tool that is very cool that is called ZombieNet. ZombieNet works with configuration files where we can specify all the environment that we want to have running. In this case, we are specifying that we are going to have a relay chain running with 2 nodes, Alice and Bob, and we are going to have our parachain that we just built running with the ID 2000 and with only one collator just for testing. Pop has that integrated, so we can just with one command run pop up parachain, and we can specify this ZombieNet configuration that has been generated by Pop when I run pop create parachain, pop new parachain. So I specify this file that is called network toml, and this is gonna launch all the network. If it's the first time you're running that, probably it's gonna take a bit of time because it's gonna download the binaries for Polkadot and run them. For me, I already built that, so it's really fast. So here we can see now, we can go to this link to see the UI of the relay chain working. Okay, so we can see that, and it has one parachain with the ID 2000 connected to it. So let's go and let's open now this other one, which is this one is our testnet, the parachain that have the contract palette on it. So let's open it. And we see here, we can see here in the chain state, when we query that we have the contracts palette on it. Right now, without any palette, we can query that. This is a UI to query a blockchain. So we can query there is no smart contracts on it. And then we can see the network explorer, and we see that is already generating blocks. So that's the first part of the workshop. We have generated a parachain with one command. We have built it with another command, and we have set up. We have up and running in another command. So now we can go into the smart contracts. I see some questions, so I'm gonna take it now about the PSP 22 standards. I will take it later now that I'm gonna talk about Ink. About how Pop will help us with the front end. Right now, Pop is not, it doesn't have it's not supporting front end development. It's only to generate your parachain run your parachain, to generate and run your smart contract, but we don't have the front end functionality on it. I'm gonna show you later then when talking about Ink, what tools you can use to interact with the Ink smart contract using a front end framework. But Pop is not supporting that at the moment. Another question I see right now for smart contract development, I'm using the substrate template node. Is Pop something similar? Pop is something similar. So Pop is, as you see, we have generated a contract parachain. When we create the Pop new parachain, we created something similar at the template node that you are using, but in a parachain version of it. Okay. So let's go for Ink. Ink is the smart contract language that we are going to use to develop smart contracts. Why Ink? Ink is basically is using Rust with some macros, some annotation that make complicated things, generate code from us. We'll see later with the code, but that means that it's inherent all the safety guarantees that the Rust programming language has. Rust, I think, has been the last 7 years one of the most loved programming language to use based on some service. So it means that Ink has the same safety guarantees and the same cool things that Rust has. It's using all the tooling that Rust has, Clippy, Crates.io. That's different with Solidity. Solidity right now has a really cool. I like to use it. It has a really cool tooling, but everything has to be created for Solidity from scratch. Ink is using all the Rust tooling one, so it's nothing very specific to. So it can get all this cool tooling that Rust has interoperability with Solidity contract. Another thing I mentioned in the first slide is that if you're developing your idea with Ink, you always can migrate into a parachain in the future if you need it. You need more performance, if you need more customization, etc. The Ink smart contract ends up compiling into WASM. WASM WebAssembly is a established industry standard for the compiler target. It's using Polkadot, but it's not only using blockchain. It's used all across the software industry. So it's a very well-known standard. And Ink is native to Polkadot, which means it complements the substrate parachain development perfectly. If you are an Ink developer and then you want to migrate into substrate, it's very similar. And the same if you want to do it the other way around. So let's take a look now. You had like the other day as well another workshop about Rust. So you probably know that when you are building a Rust program, you have the cargo toml that has all the dependencies on it, and then the code on it, the .rs files. This is an example of the cargo toml of the smart contract. It has the dependency Ink here, and then this is an example of the code in Ink. As you can see, if you know a bit of Rust after the previous Rust workshop, you probably know. I'm sure you can understand what that contract does without knowing Ink. Even if you are not a Rust, it's the legitimacy of this smart contract is very straightforward to understand. The only difference with Rust code, the traditional Rust code that we can see, is these macros that we see here: Ink contract, Ink storage. That's the macros that make that Ink smart contract that can be compiled and can be executed with the palette contracts module that we saw at the beginning of this presentation. So you can think about that is like meta programming. With this annotation, that's going to generate more code from us that we as a smart contract developers don't really need to care about. It's something that Ink is going to care. We only want to care about the business logic of our smart contract. So that's more or less how it works. So you have the smart contract here, the cargo and the lib.rs file. And when that goes into with all the macros and annotation, and when that goes into Ink, Ink is gonna generate more code on top of that. Things like how to store things in the storage, how to retrieve data from the storage. So that's gonna end up having like a bigger Rust code that's gonna compile into a WASM code. That this is what we are gonna deploy into the blockchain. So yeah, for example, something that makes very easy here if we want to manage the storage of our smart contract with that annotation IC storage, we only have to care about what data we want to store, what data types we are using. So in this case, the storage that we have for this smart contract is simple a boolean, which can be a true or false. Then we have a constructor like other smart contract language like Solidity that basically initialize a value of this storage. And then we have ways to message, which is a way for users to get the information from this storage or modify the state of this smart contract of the storage. Modify a value inside of the storage of the smart contract. So yeah, with that said, let's go to build it because it's gonna be much easier to understand Ink and to see how we can deploy and build a smart contract. We go here again. Let me open another tab so we can check. Okay, so we can check pop again, pop help. So now we want to create a new smart contract. So we say pop new contract and we call it Flipper, which is the smart contract that we saw it before. That's gonna create a smart contract. So it says move into the new folder that has been created, Flipper, and here we'll see. Let me open again the code. I can close the one for the parachain and let's open the code for the smart contract. That's a bit different the one that we saw in the slides. This, for example, has the latest version of Ink, which is the 5.0. I think was less than 2 months ago was released, and the code has a bit more information. It has a constructor that you can specify a value, and then a default constructor that it initialize the value of the boolean to false, and then have the same function that we saw before. One to get the information and one to flip. Let me put it big so it's easy for you to see it. But again, if you have pop already, you can generate one doing like pop new contract, and you can have your own contract there. Okay, once now is generated, what we want to do is build the contract. So let's do pop build contract, and that's gonna build our contract. Blocking, waiting for file lock. Okay, let me do a cargo clean because something is there pending. Okay, cargo clean. Okay, so we run the pop build contract. That's gonna build a contract. Let me build manually. Okay, now it's building some problems for the live. What this is gonna create three different files. It's gonna create a WASM file, which is the compilation of the smart contract, which is the code that we are gonna deploy. You can think, if you think like a video game, that's gonna be the game that you have to put into the console to be able to play. Then the metadata is all the information that we have. So the front end can, if you are building a UI, a front end, that's the metadata is going to help understand what's your smart contract doing, what function your smart contract has, and how to call the smart contract. And these two together create this .contract file, which is the thing that at the end we're gonna end up deploying into our blockchain. It's building. Let it finish the build. It takes less time than a parachain, so it might be a few seconds more. Okay, complete. So it says what has created, basically what I was saying. Note the size is very small. That was 35, and with optimization it end up having 10. Then we have the three files that I say, the contract, the WASM, and the JSON, and it says you where to find it. Where to find it is in this folder target, and then you can see here the inc file, the WASM, the JSON, and the contract, which is what we're gonna need to deploy the contract. Okay, so other thing that we want to check about the smart contract is obviously the testing. Testing is very important, like unit testing, to have all your functions test when you are developing. Unit testing is something that you can do it like offline, just checking the code. Let's take a look here into the code to see an example of how unit tests look like. And let's actually run the test. So with pop, you can also run the test. So you have pop test, and you see help. So you can see pop test contract will run the test of this smart contract that we are now. And while it's running the test, let's take a look into what the tests are actually doing. No? So the first one test that is testing that the default works as expected. So this constructor default should initialize the value of this value that we have in the storage to false. So we just check that, and then we check that all the process works. So we check that we initialize a value to false. We check that the value is actually false, calling one of the functions get. We flip the value, calling one other of the functions that this smart contract have, which is flip. And then we check it again. We do a get again to see that the value has actually changed. So let's run the test and see what's happening. Just 1 second more. Okay, while waiting, I see two questions more. Is there any way to implement price oracle and keepers in the centralized way in Inc contract? Yes, it is. That would have been like a cool workshop. Like it was, yeah. In this workshop, we're gonna see some basics of Inc, but we can. I think there is an example. I will try to find an example and share it with you later. But definitely you can. And another can we say that Pop is similar to Foundry? Actually, yes. Yes, I haven't used Foundry to be honest, but it is like the goal of Pop is to make the whole development on Polkadot easier, like Foundry is doing for Ethereum. Okay, so test has passed. All the tests are okay. I always like to check that the tests are really okay, so I won't make the test fail to see that there's nothing wrong in the code. So I just change a variable here and see that, okay, that test, it works, it fails if I put the wrong values. Then we have the end-to-end test. End-to-end test, we're not gonna test it now because for the end-to-ends we need to compile the smart contract with this feature end-to-end test. We need a software node running, and then we can run the end-to-end, which basically is gonna try to compile, instantiate the smart contracts, and then do the same calls as we've been doing with the unit test. Okay, so now we have testing. Let's deploy the contract in the parachain that we have running here. So we see we have this parachain that has been producing blocks since the beginning. It has no contracts yet. So let's deploy our first smart contract. We go to pop, we do pop up contract, and we specify the flag help to see what we need to include to deploy a smart contract. So first of all, we have to call a constructor because we are deploying and instantiating a smart contract. So we want to specify the constructor that want to be called with the arguments that we want to call it. Value is in case we want to transfer some balance into the smart contract. Then we can specify the maximum amount of gas that we want to use with gas and proof size flags. If we don't specify that because we don't have an estimation, what Pop is gonna do is to perform a dry run before to do an estimation of the gas that is gonna consume and use this gas by default. And then we're gonna specify where we want to deploy the smart contract, passing the URL, and who is gonna deploy the smart contracts, passing the secret key of the account, basically the wallet that is gonna deploy this smart contract. So let's do pop up app contract. We call it first the constructor new. We call the args at false, which means that we are calling this function new to initialize the value to init value, which is false. Then we are gonna add we don't add the gas. We let Pop to do the estimation for us. So we add the URL. The URL by default is this WS localhost 944. Our blockchain is running in localhost, but the port we can go see that the port is not 944, it's 56799. So we change that here. And we have to use the wallet now, because it's testing mode, we're gonna use testing one, which is Alice. So we specify SURI Alice to specify the account that is gonna deploy this smart contract. We run it, as you can see, it's doing a dry run to estimate, and this is the gas that is estimating, and then contract is deployed, and we have the contract address. We can go here to Polkadot.js to see the front end, and we can see there's some events. So some codes has been stored, a contract has been instantiated. So we can see that everything has been successful. We can also go to interact with this UI to query the blockchain and see all the contract that has been deployed here, and we can see this address JU56JU, which is the same address that we have here. So the smart contract has been deployed into our testnet or local testnet. Okay, so let's now interact with this smart contract. So we have pop call option, pop call contract. Let's see again the help to see what we need here. So very similar to before, but we have to specify the contract, the address of the contract. We have to specify what functions we're gonna call with the flag message. The function with the flag message are this one, flip and get, with the arguments if applies, and then same with the gas. If we don't specify one, it's gonna do a dry run to estimate the gas. We have to specify where and who is gonna where this smart contract is deployed and who is gonna be the one executing this functionality. So let's change a bit okay, let me do clear so it's clear for you. But let's do what we have before, but modifying. Instead of pop up now, we are gonna do a pop call. Instead of constructor, we need now a contract, and we need the address of the smart contract, which we can get it from here. Next thing we have to specify is the message that we want to call. In this case, get. This message get, we can see here it has no arguments, so we remove this part. Where, the URL, and who. Let's change the who. We deploy the smart contract with Alice, but let's do the calls with Bob account. Contract message, Uri. Did I miss something? Contract message. Yeah, this is wrong. Pop call contract help. I wrote it wrongly. URL, yeah. There is one extra token here. So the contract is the message is executed, so we get the result. So we are executing this get. So we are simply returning the value that we are storing in value that we have in the smart contract. So we have it here in false. Let's flip it now. So let's call another function instead of get. Let's call flip. Because this function, the function before was only a read, it doesn't have to be executed, it's just a query. Now we are actually modifying the state of the smart contract, so we need to specify that we want this function to be executed in the blockchain. So we specify that. It does the same, try run to specify, to get the estimation of the gas. And then it's calling the contract, so everything looks good. We see some events has been called. We can check it here too. So we see that the contract has been called. The events are happening here. And let's just see again with the get if the value of the storage has changed. And we see that it was false before, now it's true. So we are interacting with the smart contract what we just deployed. Okay, cool. So now that's it about Ink. It's very basic, but only have 1 hour for this workshop, and already been like more than 30 minutes. But I encourage you to take a look into the documentation, use Ink, and then if you want to do more complicated things, you can contact me again. I'm going to be a mentor, so I'm going to be available in Discord all the time. Some things that from the questions before that I want to show you from the documentation. So, I mean, you can see here everything from the documentation, like the basics, how to the events work. You can see the macros that they're explaining, but more in detail. And something that was in one question about the front-end development. I encourage you to go here because here there is like information of the different tools, the frameworks that you can use for front-end developers with some examples. Check this here, smart contract example section, where you have more complicated or more interesting examples than the one that we just saw that was just a flip a value, a Boolean value. So here we can see things like cross-contract calls, upgradable contracts, something like an ERC20 that has a bit more of complex thing inside. So see the struct now, it has balance, it has some mappings to map all the, to track all the balances, different events, different errors, etc., etc. And the interesting part here, we have also a front-end example. So you can actually go here and have like a front-end example of how to interact with a smart contract that you can use to build in that hackathon. Okay, so yeah, the second part of the workshop, that's it. Now we are gonna see, okay, how to deploy that on a testnet, because probably you're gonna want that for the end of the hackathon, not just have everything running locally. You want to have something to show the rest of the people, to show to have some users already playing around with your application. So how we can deploy that on a testnet. So here's the second part of the POP platform. We've been using the POP CLI, which makes very easy to create a smart contract, to deploy it, to call it. It makes very easy to generate a parachain and make it work locally. Now we can use POP network to really deploy your solutions there and have some platform to deploy our smart contracts. Deploy the smart contract using Dot. These smart contracts will have some what we call POP API that will make these smart contracts available to the whole power of Polkadot and to use all the different cross-chain use cases. So, for example, we'll be able to mint an NFT in another chain, in Asset Hub system parachain, for example. And access Polkadot Power, what that means is that this smart contract will be deployed on the POP network, interacting with underlayer, which is called the POP API, that can interact with other functionality like runtime logic, NFTs at runtime level, cross-chain assets, etc., etc. That's the documentation. I encourage you to go learn.onpop.io. I just give you a quick look on that before we really go and deploy smart contract on a testnet. Here in the CLI, you can see basically what we told, how to create a new smart contract, how to test it, how to deploy it, and the same with a parachain. And in here in network, you can even see to create a bit more complex smart contract, how to create NFT smart contracts in your chain. Okay, learn on pop.io. That's the documentation. And okay, let's deploy the smart contract now. Let's go into the third part of this workshop. We're gonna go into this website onboard.popnetwork.xyz to get tokens. So as I say, Pop Network is still not in production, but we have something. We have the parachain up and running in a testnet in the Paseo testnet. The Paseo testnet is the Polkadot testnet, new testnet. So if you open Polkadot.js, you can go here and you can see, you can go to Paseo, which is the testnet from most similar to Polkadot. You can open it, and here you see Pop Network. So you can actually go here and interact with Pop Network. So the first thing of all, I have tokens here, but I will show you how to get tokens. You need tokens first in Paseo, and then you have to move the tokens from Paseo to the chain. That's because we are using the native token of the parachain. Once it's in production, it's gonna be the same with DOT. So you can move the DOT from the Pop network, from the Polkadot chain to the Pop network chain with this UI. So first of all, if you don't have Paseo, open the official faucet to get Paseo. And here is as easy as pick, it's not Rococo, pick Paseo, pick the Paseo relay chain and add your account here. Says that you are not prove that you are not a robot. Okay, I already request a lot of funding, but probably you can still request some funds. And then let's take it from Paseo to Pop Network. So you go here again, copy. Well, you don't need to copy, sorry. You can connect your wallet. I have here the Polkadot GS extension. So basically we'll go here, pick my account and the amount to send. So I pick 10 Paseos. I have to sign the transaction. And that has been success. So I can go here and I see that I have some fundings already here. So I can deploy a smart contract on that. To deploy a smart contract, you can do the same that we've done in the workshop, in the part 2 of the workshop. Just use POP, just use the command line. If you don't like to use the command line, there is a more visual way to do it. I like to do sometimes things in the UI. So you have this UI.use.inc that we are going to see now. And here you can deploy a smart contract with a nice UI. You can do the same locally that we did in the workshop 2. Basically, you have to specify here instead of the default port, the one that your local parachain is using. And if you want to deploy in some production networks, here you have options to connect to Astar, to Aleph0, etc., etc. You wanna, in that case, we are gonna deploy in that test network. So we go to some of the test networks, and you can pick wherever you want to deploy your smart contract on. I'll pick Pop testnet here. That's gonna load. Everything is connected to the Pop network testnet. So let's upload a new contract. We go here, we pick our account. That is getting, because I connected with the Polkadot.js extension. Give the contract a name, Flipper. Upload the contract. So we go here, and again, you have to go find where is this Flipper.contract that you have compiled, that you have executed when you run the pop build contract. and you have to pick the Flipper contract, because remember, Flipper, the dot contract file has the wasm file and has the metadata, and you will see how nice it looks like now. So you pick that, and then you can see that it's parsing all the metadata, so it understands the contract, it understands all the functions that we have, new, flip, and get. Sorry. And then you can upload and instantiate the contract. So we upload it. It does as Pop did. It does a dry run to estimate the gas that it's going to consume. You can change it here, but you can use the estimation one. So you click next, and then you can select here how to instantiate. So I'm going to instantiate the constructor new, and I'm going to put the value to false to start. Okay, it gives you here the data. So you go update and instantiate, and you have to sign the transaction to actually upload the smart contract. Okay, so contract has been uploaded now. We can go interact with the POP network here, and you can see this has been there's already 17 contracts. So one of these 17 it's our contract that we just deploy now. We can interact with this contract. We can use Alice or Alex to call to, let's say, let's do a get and see what's the value. We see the value is false. Okay, so let's do now the same as we did before with POP with this nice UI. So let's flip the value. For that, we'll have to send a transaction that has to be signed to the blockchain, because we are going to alter the state of the smart contract. Executed. Okay, everything went okay. So let's see now if the value is true. Yeah, so the value is true. So now we can interact with this smart contract with this nice UI. Okay, so yeah, with that is everything. Like same I've been doing now with the UI. You can deploy to any parachain that you want, even in a production one. Same with the POP tool. If you prefer to do things with a CLI, you can use the CLI to deploy these smart contracts. Here on the left, I have a QR with all the social networks that we have for POP. So you can go check our Telegram if you need help, if you need support. Check our Twitter if you want to see all the news, because we are still developing, so you can keep updated and see all the new features that we've been adding into POP. On the right is my social networks if you need more help. I only touch basic of a smart contract. I'm sure you're gonna have doing so more cool things, and you probably will need some support. And I will be very happy to help with that. I'm gonna be around Discord and happy to see how you are building things, and happy to hear from your feedback when you start using POP for that.